All right, today I'm going to walk you through an example for a limiting reactant stoichiometry problem. And this one actually involves the lab that we did where we reacted aluminum foil into a solution of copper chloride. And we wondered how much product would we actually make given our different amounts of starting material. So just something to note about these limiting reactant problems. In first semester, we did do stoichiometry and we did do gram to gram problems, which is what we're going to do in this problem. The only difference is now it's telling me I'm starting with 2 grams of one of my reactants, but then it's also telling me how much I have of the other reactant. And that is novel, that is new for us, because in first semester, we would always tell you how much you have of one of the reactants, and then we would say the other one was in excess, or you had plenty of the other one, or we might not even mention the other one at all. So you knew the calculation only involved one of them. For these problems though, since it's giving us 2 different amounts of starting material, I need to know how much product each of them can make, because unless they run out at the same time, one of them will limit how much product we can make. And then one of them, we will have some left over at the end because it doesn't get all used up. I do have the steps up here of how to solve these. I'll just cross them off as we go to try to help you out with that as well. So this is assuming we start with 2 grams of copper chloride and 0.45 grams of aluminum. Determine the theoretical yield, or how much we could produce mathematically of copper. So we're trying to figure out how much copper can we expect from 2 grams of my copper chloride and 0.45 grams of aluminum. So when I look at step number 1, it says to solve for the mass of product twice, once using the mass of one reactant and once using the mass of the other reactant. So I need to know, given 2 grams of, 0.45 grams of aluminum, how many grams of copper will that make? And then 2 grams of copper chloride, how many grams of copper will that make? And so I'll have to figure both of those out separately using the math that we learned from first semester. So nothing new in terms of how to solve it, just now we have to do 2 of them. All right, so I'll start with my 2 grams of copper chloride. And this is a gram to gram stoichiometry problem. So I need to know how many moles 2 grams is of copper chloride. Then I will relate my copper chloride to copper using that mole ratio, the coefficients in the balanced equation. And then once I have moles, I will then go to grams using molar mass. Okay, so I know that 1 mole of copper chloride is equal to, and I've already calculated this in the periodic table beforehand, 134.45 grams of copper chloride. Remember, the unit that you're trying to cancel will always go on the opposite side of the fraction line, and you should cross those units out as you go. It kind of helps you see where the problem is going next. So now I'm in moles of copper chloride, and I need to relate it to the copper because that's what the problem is asking. So I know from the balanced equation, my mole ratio, for every 3 moles of copper chloride, I will produce 3 moles of copper. My last step is to go to grams. I know that 1 mole of copper is equal to its molar mass in the periodic table, 63.55 grams. The units are super important on this. So not just moles and not just grams, but moles and grams of what substance. And you need to be writing those formulas for every substance throughout that stoichiometry problem, just like we did in first semester. So I'm ready to solve. I multiply everything in the numerator, divide by everything in the denominator, and I get 0.95 grams of copper. So theoretically, if I have 2 grams of copper chloride, I will make 0.95 grams of copper. Okay? And in first semester, we'd be done. But now we know how much of the other material we have as well. So I need to figure out, well, how much product will that make? Because if it can't make this much and it runs out first, I'll actually be limited by the other one. So I start 0.45 grams of aluminum. I will want to go to moles. I know that every 1 mole of aluminum is equal to its molar mass in the periodic table, 26.98 grams. Then I will relate my aluminum to my copper using the mole ratio. For every 2 moles of aluminum, there are 3 moles of copper. And then finally, I need to go to grams of copper, and I know that 1 mole of copper weighs 63.55 grams. Now I will multiply everything across, divide by everything on the bottom, and I get 1.59 grams of copper. I need to get a little bit smaller so it will all fit here. Oh dear. Sorry, friends. Oh dear. Okay, I almost gave up, but I'm glad I didn't. Okay, so now I have done step 1. Now I want to see which reactant produces the smallest amount. So when I look, I see that my 2 grams of copper makes 0.95 grams. Or sorry, 2 grams of copper chloride makes 0.95 grams of copper. My 0.45 grams of aluminum could theoretically make 1.59 grams of copper. So that means my smaller amount clearly is 0.95 grams. So this is all that I can make. We call this our theoretical yield. And that is because I can't make 1.59 grams because I'm going to run out of, let's see which reactant made this, my copper chloride. After it makes 0.95 grams of copper, there's no more copper chloride to react with the remaining aluminum. That makes this my limiting reactant. And that makes this, of course, my excess reactant, which means it will still be left over when the reaction is done. So I would still see aluminum floating in the solution. And then when we dry it out on a filter paper, I would still see that shiny silvery metal because it would still be present and left unreacted. The smaller amount is our theoretical yield. We also said that. So hope that makes sense. Again, just like any calculation we did first semester, just we have 2 different starting amounts, and so we need to know how much product each of them can make. Okay, I did write my limiting reactant down here and my theoretical yield up there, so you can just refer to that. Hope that makes sense. Send me an email if you have any more questions, and have a great day.